This right here is my Coherent laser diode module. It's actually a Coherent laser diode array. There's a set of laser diodes in a stripe that are inside this module. It's a fairly large unit, supposedly capable of around 60 watts. Today we won't be making that kind of power because I don't have the power supply capable of generating the amount of current that it needs to run. Supposedly it takes about 90 amps to get it to around 60 watts. Right now I only have about 60. Diode is a infrared laser. It puts out around 808 nanometers of infrared light, so you can't see the beam. To the naked eye there is a faint red glow that comes out of it, but it's very deceiving because the beam is actually way brighter than it appears to the eye, and you need safety goggles to be able to properly operate this laser. This right here is the cooling system that I just finished for the laser. No, I didn't build the whole entire thing. It just had some problems with it when I got it, and I replaced the thermoelectric units inside of it that cool the water. Right now it's running at about 21 degrees Celsius, which is about the right temperature for running the diode. There are the water cooling lines right there running to the laser diode. And then from here we go down to the power supply. This right here is the Sorensen power supply that I purchased for running this unit. It generates 0 to 10 volts DC at about 0 to 60 amps, and the diode itself draws around 2.5 volts of that, and as I crank up the current, the power also goes up. These are the 10 gauge wires that are running to the laser diode. It draws a lot of current in order to produce that kind of power. And in a minute I'll show you it running, but first off, the most important piece of this whole project are these right here. These are infrared laser safety goggles. If you do not have a set of these, don't even bother trying to power up one of these, because this laser is extremely dangerous to your eyes and can surely blind you. I'll be back in a minute and we'll go ahead and power up this laser diode, and I'll show you cutting some stuff. Okay, now I have my laser safety goggles on, and we'll go ahead and show you this sucker working. Alright, first thing we do here is we turn on the main power to the diode, and there we'll crank up the current just a little bit. Remove the jumper just to make sure that there's no spikes to the diode. Then from here we can start turning up the current. Now you won't see anything, but to the naked eye you would see a faint red dot. The focusing lens that I have here kind of stinks, but it's doing an okay job of burning stuff right now. I got it focused here on this brick. In a minute, as I start turning up the current, you'll see the brick actually start to heat up. So right now we're at 4 amps. Let's get it up to around 20. That's about the threshold for this laser. And from here, now you'll start to see the brick heat up. It's 30. You can see the brick starting to get red. It's 40 amps at 2 volts. And we'll keep cranking it up here. It's about 50 amps at 2.2 volts, and as you can see, the brick is white hot. And if we put a piece of cardboard in front of it, it doesn't like that too much. readily burns cardboard. Oh, got a little fire going. Okay. So, we'll go ahead and turn the diode back down now. So anyway, that concludes the first test of my giant coherent laser diode array. And a couple more days I'll post some other videos, waiting to get a better focusing optic for it, and hopefully I'll get around to eventually pumping a YAG rod and then frequency doubling that with a KTP to get about maybe 10 to 30 watts of 532 nanometer green, which would be just about awesome. And there you go. Please feel free to post any comments on my YouTube video. If you have any questions, I'd be glad to answer them for you. Thanks!